So today we're going to do long division of polynomials, which is nice because you've done long division before. So you started long division when you were younger, but you didn't have any variables, you just had numbers. So if I were going to divide 4,262 and I were going to divide that by 25, I have my 25 and I'm dividing it into 4,262. You guys okay with setting that up? Yeah? The divisor is what's on the outside. So in this case, it'd be the 25. The dividend is on the inside. So in this case, it'd be the 4,262. And you don't see that vocabulary a whole lot, but sometimes they might use it in a question. The quotient is the answer, and that's going to be on the top. So when we're done, it'll be on the top. The remainder, the leftover, there are different ways to write that, and I'll show you how we write it for division of polynomials. Like for numbers, sometimes they would use like big R or equals, or we would add a decimal place and add some zeros and keep going. But for polynomials, it's similar. So let's go ahead and we'll divide 25 into 4,262. So it won't divide into 4, it divides into 42 once. So 1 times 25 is 25, and then I subtract. So I'm going to change colors, but you'll see we're going to do that when we use polynomials. So when I subtract, that leaves me with 17. And then I have to bring down the next digit, so I'm going to bring down that 6. And so now I ask myself, what would I multiply 25 by to make 176? Well, I can't, but I can get pretty close. If I multiply it by 7, I'm going to get 175, and then I have to subtract. I bring down my 1, and the next digit is 2. So I can't divide 25 into 12, so that would be 0. So when you were younger, you might say my quotient is 170 with a remainder of 12. And then when you got a little older, they said, well, you don't really have to stop there. You can add a decimal and a 0 and bring down the 0. And so that would be, I put my decimal up here also, so that would be 4. 4 times 25 is 100. I'd have a remainder of 20. I could add another 0 and extend that. And when I bring down that 0, it divides evenly 8 times 25 is 200. So I get a remainder of 0. So when you got a little older, you could write 170.48 is your answer. And so today we kind of do a mixture of that with polynomials. It's kind of like writing 170 plus 12 out of 25. So that's what we'll do. We'll take our remainder and we'll write it over our divisor. And if you take 12 and divide it by 25, you get 0.48. So it's really kind of the same thing. Okay, so the steps are very similar for dividing polynomials. One thing that we have to check for that's very important is check to see if you need placeholders. Okay, sometimes you need placeholders. So the divisor and the dividend. So you have to check both of them. Should have all descending degrees. And if not, you use a placeholder. And so we'll look at a problem where you have to have a placeholder. But so you always want to check to see if you need placeholders. Your divisor and your dividend should have all descending degrees. So when I look at this problem, I'm checking the degrees. I have degree of 3, 2, 1, because that's an invisible 1, 0. That's good. Okay, 3, 2, 1, 0. That's what I need. My divisor is 1, 0. Perfect. Okay, so if I didn't have one of those, I would have to put a placeholder in. Like when we do the second problem, this one goes 3, 2, 0. That's not okay. So you have to add plus 0x. That's what I mean by a placeholder. It has to go 3, 2, 1, 0, or it won't work. And you always have to check the divisor also. So this one goes 1, 0. So that x minus 3 is good. So sometimes you have a placeholder. You can have more than one placeholder too. You have to account for every degree. Okay, so let's go back to our first problem. So we're going to set up, we're taking, they're asking us, is 2x minus 7 a factor of, so what they mean is take 2x minus 7 and divide it into 8x to the third minus 16x squared minus 10x minus 112. Okay? If it divides evenly, God bless you, it's a factor. So this is what you do. I want to divide 2x. I want to take my 8x cubed and divide it by 2x. That would give me 4x to the second. With me? So now I'm going to multiply, just like we did with the 25. 4x to the second times 2x gives me 8x to the third power. And then 4x to the second times negative 7 gives me negative 28x squared. Okay, so I'll get that in a second, sorry. So then I draw my line underneath, and then I'm going to change signs. So it's just like in the division problem up here, I want to subtract. But when I'm subtracting that whole expression, I have to distribute my negative signs. So this is where you want to use another color. Minus, distribute your negative sign, sign change. Okay, so because I'm not just subtracting the first term, I'm subtracting both of them. So it's like I'm distributing that negative sign through that expression. And then I add down. So these cancel, and this will make 12x squared. So then, just like in my other problem, I bring down my negative 10x. So now I'm going to look at it again. 12x squared divided by 2x gives me positive 6x. So 6x times 2x. Mm-hmm. Well, when we combine like terms, we keep the ending. Okay, and that's one of the ways you'll know if you need a placeholder, if you forgot to put a placeholder in, is because the terms won't be like, and you'll be like, oh, something's weird about this problem, it doesn't look right, and then you'll go back and it's a placeholder. Okay, so we're just taking our negative 16x squared and adding 28x squared to it, which gives us positive 12x squared. Yes, ma'am. So my 8x cubed minus 8x cubed cancels. It's 0, right? Here I have negative 16x squared. That's from my original problem. And then, so when I multiplied that 4x squared, Skylar, I had to multiply it by both terms. So this one gives me my 8x cubed, and this one gives me my negative 28x squared. And so when I subtract down, it's negative 16x squared plus 28x squared. Oh, did I'm sorry. I just multiplied it. Oh, because we did that after. Okay. So look at it again. So on this line right here, maybe we went a little bit too quick, and then the beeping started, and sometimes that's distracting to me too. I'm sorry. So when we multiply, we have to multiply whatever's up there by both. Okay, so the 4x squared times 2x gives me the negative 8x cubed. And then the 4x squared times negative 7 gives me the negative 28x cubed. Let's see, if I can pull. I think I'm good. Hannah, I can get that work together for you to take with you, but can I talk to you about it a little bit later?
Oh, I can.
You came to take a quiz. Okay, what quiz do you need to take? Okay, awesome. Let me grab that for you real quick. Okay, sorry guys, I'm just not real comfortable with losing the recording of the notes because this is my last chance. So I'm just going to let it run for just 1 second while I grab our quiz. Here you go, Hannah. I'll let you sit right here. All right, sorry about that. Okay, so Mia, do you see where we get the 28x squared?
Yes, but how did you get the 4? I don't know. I kind of got lost here going past it then.
Okay, no, that's okay. Let's back up a little. All right. So it's like my original problem, Mia, with the 25. I'm dividing this, and I always look at the very first term. So what do you need to multiply 2x by to make it match 8x to the third? Is kind of another way to think of it. So I need a 4 times 2 is going to give me that 8. And then I need 2 more x's. I need x to the power of 2. So now I'm multiplying that 4x squared by that whole expression, and I'm going to write it underneath. Does that kind of help? Okay. And, raise your hand if you need me to go back over something, because I totally don't mind, and I want you to get it. So 4x squared times our 2x gives us that 8x cubed. And now here I get my negative 28x squared. And so this is where I think if you use a different color, it kind of helps you keep track of your sign changes. Yes, Lena. Because I only multiplied the 4x squared by the 2 terms. Okay, so now we're going to stop and we're going to subtract. So I'm subtracting the whole expression, which means the 8x cubed becomes negative, and the negative 28x squared becomes positive, because I have to change signs. So when I subtract down, these two are going to cancel out, and this gives me, we said, positive 12x squared. Now, it's like that original division problem we looked at. I bring down the next term. So I've got my negative 10x. So now I need to look at it again. What do I multiply 2x by to get that 12x squared? Okay, so I have 6x times 2x, which gives me 12x squared. But I also have to multiply it by the negative 7. So I get negative 42x. And now I'm going to change signs. So I have negative and positive, okay, because I'm changing the signs. So now I'm going to subtract down. These two cancel out, 12x squared minus 12x squared. You guys good with that? And then negative 10x plus 42x gives me a positive 32x. And now I'm going to bring down my next term. So I have minus 112. So now I need to look at it again. What do I multiply 2x by to make it 32x? 16. Good. Now I already have the x, so just 16. 16 times 2x gives me 32x. And 16 times the negative 7, what's that? Is it positive or negative? Good. Negative 112. And so now you can kind of see where that's going. This is going to be a sign change, and my remainder is 0, which means to answer that question, is it a factor? Yes. Yes, it's a factor because the remainder is 0, or there's no remainder. Okay, so that's how you know it's a factor if it divides evenly. What do you think? Okay, sometimes there will be a remainder. If there's a remainder, then it's not a factor. So let's look at this second example. This one, we need a placeholder. So we're going to take x minus 3, and they're asking us, is it a factor? Prove it's a factor by long division. So if I divide it into 2x to the third plus x squared, I have to use my placeholder plus 0x because I need that power of 1. Would I have a remainder of 0? So first I look at that x and the 2x to the third. What am I going to multiply this by this to make it match? Good, 2x squared. So 2x squared times x gives me 2x to the third. 2x squared times negative 3 gives you negative 6x squared. Okay, so now we have to subtract. So if you use your other color, it just kind of helps you because if you change signs with the same pencil, sometimes you forget what you changed it to because it gets all, the work's kind of long and it gets a little smudgy. So this cancels out when we subtract, and this leaves me with 7x squared. I bring down my plus 0x. So what goes next? Mia, what do you think? What do I need to multiply x by to make 7x squared? Good. 7x. So when I multiply, I get 7x squared. And then 7x times negative 3 is negative 21x. And then change colors so you can see your sign change real clear. Subtract, add. Mm-hmm. Yeah.
So it's not that whether you're subtracting or adding, all these things sound like it's really not top. The second chart.
Well, because it's division, like our original problem with the 25, you're always going to be subtracting, okay? But think about it like this, Lena. When you look at a problem like this, maybe let's look at this one since we already did it. It's like you're distributing that subtraction. So negative, right? And he's negative underneath, positive. Okay, it's like you're distributing the subtraction, but you're always subtracting with division. Now, if that first term happens to be negative, when you distribute that subtraction, it's going to be positive. It's going to be a sign change. Yeah.
For our third example, so it's automatically subtraction, like 7x squared plus 0x minus 7x squared. Why is it the top negative, like 2x squared minus 7? What does that make? That's 7x.
Go back and look at a long division problem with numbers. 1 times 25 is positive 25. It's not negative 25.
Yeah.
Then we subtract. You see what I mean? 7 times 25 is positive 175. Then we subtract. Do you see what I mean? So they're very similar. But yeah, you kind of, and the more you do, you'll get more comfortable with it. So these would cancel out, and here, we would have positive 21x. So this is why we need that placeholder. Otherwise, we'd have a negative 20 here, and you would be like, what? Negative 20 minus or plus 21x, those terms don't go together. So usually you can figure out if you missed having a placeholder because your problem will start to look kind of weird. And then you'll put the placeholder in it. Okay, so for our last time, what will we multiply x by to make 21x? 21, good. And so we get 21x, and then 21 times negative 3 makes negative 63. And so on this one, you can tell we're going to have a remainder. So we're going to subtract, add, and then when we bring everything down, cancel, and we get positive 43. So the way we write remainders, because we're not going to like add is decimals, and we're not going to do big R of 43, it's a positive 43 x minus 3. Okay, that's what would be left, the 43 divided by that. So you just put it over the divisor. Okay, so this is polynomial long division. So you just write the remainder over the divisor. So we have one more example. So we should check for placeholders. I've got 4, 3, 2, 1, 0. Good to go. But you have to check the divisor. 2, 0. You've got to have a degree of 1. Okay? And someone asked me, you can use plus or minus 0. It doesn't matter. It'll be the same thing. So is x squared plus 0x minus 3. Oh, we forgot to say that last one. Is it a factor? No. Not a factor. Because it has a remainder. Remainder, not a factor. So let's look at the next one. So we'll go ahead and set that up. Thank you. Can you run that errand, please? Thank you. I'm sorry, that was probably that little message I got earlier that I didn't answer. And it looks really long, but interestingly, because you're dividing 3 terms into it, you're only going to do it like twice, because you've got 3 terms divided into 6. So it looks kind of long, but it's actually not that bad. Okay, so what would we multiply x squared by to make 2x to the 4th? 2x squared, good. So now we just have to multiply all 3. So we get 2x to the 4th. 2x squared times 0, x is going to make 0, x to the 3rd. And then 2x squared times negative 3 makes negative 6x squared. Okay, so we needed that 3rd degree placeholder. So now we subtract, so change colors, and we'll change our signs. Negative, negative, positive. Cancels. I think that's supposed to be a 4, sorry. Cancels. And so when I add down, this will be 9x to the 3rd, and then this will be negative 18x squared. Okay, now we're going to bring down our next term, negative 27x. And so we'll do it again. What do we multiply 9x to the 3rd by to make x? What do we multiply x squared by to make 9x to the 3rd? 9x, good. So we need 9 and another x. So we get 9x to the 3rd, 0x squared, and 9 times negative 3 is negative 27x. Okay, so now we're going to change signs. Minus, minus, doesn't really matter with 0, but we can change it anyway, plus. And then we add down. So these will cancel. Here we get negative 18x squared, and here we get plus 0. X, and then we bring down the plus 54. Sorry, I try to switch sides so I'm not always kind of standing in front of it for one person. So the 9x cubes canceled out, then we had negative 18x squared, and then our 27x is canceled out. So now we just have 0x and then plus that 54. So now, what am I going to multiply x squared by to make negative 18x squared? Good, negative 18, so I get negative 18x squared, 0x, and then what's negative 18 times negative 3? Positive, is it 54? Good. So we change signs. So this becomes addition, subtraction, subtraction. So everything cancels out that's left. You get a remainder of 0, which means, yes, it's a factor. No remainder. It's a factor. So on the bottom of this example, they asked you to keep factoring. So it's factor completely to find all the roots. So we know that the original is 1 factor, x squared minus 3. So it's kind of like the Yoshi worksheet. X squared minus 3, that's 1 factor. And we know that our quotient up here is a factor. So 2x squared plus 9x minus 18. So we have this 2x squared. What was it? Plus, I can't remember. Plus 9x minus 18. So we're going to factor that further. So what multiplies to negative 36, but adds to make a 9? What do you think? 12 and negative 3. So we factor this further. This is a swing method. So we're going to set up. We have our x plus 12, x minus 3. And now we divide by the a value. So divide by 2. And then we would reduce. So we get x plus 6 times 2x minus 3. And then this is my other factor. So these are all the factors. Okay, so factored form. And then if they ask me to solve it, or for the solutions, this one you guys are pretty good with, right? Negative 6, 0. This one is like the Yoshi worksheet. So you add 3, and then divide by 2. So this one is 3 halves, 0. And then this guy is the one that's a little bit weird. If I take that x squared minus 3 equals 0, I add 3. Oops. So I get my x squared equals 3. And then I take the square root. So plus or minus the square root of 3. And so this one would be, I'd have positive square root of 3, 0, and negative square root of 3, 0. Okay, so those are my 4 roots. We kind of stopped there on Yoshi and just wrote them together. But if you look at the top, we divided, it was a 4th degree polynomial, right? So if it's a 4th degree polynomial, we should have 4 roots. So you could probably stop here and that would be fine with the plus or minus the square root of 3. There's 2 like that on the back, but the other ones you just have to factor, okay? So why don't you do what I told my class yesterday is do on your it's Mario Kart. Do 1, 2, and 3. Don't do 4. And then do 5. And don't do 6. And so we'll go over those tomorrow in class because I think this is kind of tough. Instead, use some homework time to maybe look at the review in advance and see if you have extra questions. Okay?